In the world of massive industrial systems, some of the biggest dangers, they start with a problem you can't even see, a tiny, invisible gas leak. So, what if the best way to find it is with something as simple as, well, bubbles? It's time to start the investigation.
That's the real question, isn't it? In these super complex networks of pipes and valves, a leak isn't always some dramatic hiss or a big visible cloud. Nope, it's usually silent, completely hidden, and incredibly dangerous. It's basically a detective story, and our first job is to figure out how to make this invisible culprit finally show itself.
And this just hits the nail on the head. Just because you can't see the leak doesn't mean you can't see its consequences. These tiny little escapes, they can lead to equipment failures, serious environmental damage, and major safety hazards. The threat is very, very real.
All right, so first, let's really get to know the enemy we're up against. What exactly are the stakes here when we're talking about these silent dangers lurking in our most critical systems?
A small problem can spiral out of control fast. A minor leak, it can put workers on site at risk. It can release all sorts of nasty stuff into the environment. It forces entire systems to shut down for repairs, which, as you can guess, leads directly to huge financial losses. Every single one of these is a massive headache.
So, where are these little troublemakers hiding? Well, they love to hang out pretty much any place where two things connect. Think about it. Weld joints, the gaskets between pipes, those tiny little threaded connections for instruments. Every single one is a potential failure point and a perfect hiding spot for our invisible threat.
Okay, but for every problem, there's a solution. And in this case, it's just beautifully simple. Let's introduce the hero of our story, the bubble or foam solution test.
So what is this thing exactly? Well, here's the breakdown. The method really has two key ingredients. First, you gently pressurize the system with some low-pressure nitrogen gas. Second, you go and apply a special leak detection solution to the outside. That's it. Simple, right? But as we're about to see, it's incredibly effective.
And this is the core idea. In a nutshell, it's the exact same principle you'd use to find a hole in a bicycle tire, right? You put it in water and you look for bubbles. If gas is getting out, it has to push through that liquid solution, and when it does, poof, it makes a bubble. It's basic physics, and we're just using it to our advantage.
So, how does this actually work in a real-world industrial setting? Well, the test isn't just about randomly spraying stuff and hoping for the best. No, it's a clear, methodical process. It's the playbook for our leak detectives.
This 6-step method is the whole playbook. First up is prep. Isolate the system, hook up your precise gauges. Then you slowly, gradually pressurize with nitrogen. Step 3, this is the magic moment. You apply the leak detection solution, often a product called Snoop, which is kind of perfect, to all those potential hiding spots. And after that, you just watch. If you see bubbles, you've found your leak. The final steps are just as important. Repair it, retest it to make sure you got it right, and then document everything. It's a complete professional process.
And hey, notice the pressure here, just 5 to 10 bar. Now, to put that in perspective, that's way less pressure than you'd get from a typical pressure washer. This is a gentle, low-pressure check, which makes the whole procedure a lot safer. It's just enough pressure to coax the gas out of any little hiding spot.
And check this out, the results couldn't be clearer. It's night and day. On the left, if there's no leak, the solution just sits there, the system's tight. But on the right, if gas is escaping, you get a clear, undeniable visual signal, a stream of continuous bubbles, or maybe a growing patch of foam. There's zero ambiguity. You found your culprit, and you know exactly where it is.
Okay, so we've established that the test is simple and the results are crystal clear. But what makes it a go-to method in the industry? Let's look at the secret weapons that make this technique so powerful.
This really is the key question. Why does this low-tech approach beat out more complicated methods in so many situations? Well, the answer really lies in its two main components, the gas it uses and the natural advantages of the method itself.
So first, let's talk about nitrogen. It's pretty much the perfect gas for this job. For one, it's inert, which means it's not flammable and it won't react with any chemicals in the system. Huge plus. It's also totally dry and clean, so you're not introducing moisture or gunk. And on top of all that, it's safe and you can find it just about anywhere. It's the ideal partner for this kind of work.
And the advantages of the test itself? Oh, they're just as compelling. It's sensitive enough to find the tiniest, most minuscule leaks, and you get that instant visual confirmation. It's fast, it's cheap, and you don't need any complex, expensive equipment.
Best of all, you can use it pretty much anywhere, even in really cramped spaces where other detectors just can't reach. It's a masterpiece of practical engineering.
So we know how it works and why it's so good. Now let's look at where it's actually used out in the field and the critical safety protocols that always go along with it.
And the answer to where is it used is pretty much everywhere, seriously. From critical fuel gas lines in a refinery to the super delicate instrument tubing that controls the whole process. It's used on HVAC systems, firefighting equipment, huge compressor packages, you name it. This versatility just shows how essential this simple test is across dozens of industries.
Now, even though it's a low-pressure test, safety is absolutely non-negotiable. Professionals always use controlled pressurization, carefully calibrated gauges to monitor it, exclusion zones to keep people safe, and of course the proper protective gear for the technicians doing the work. Remember, simple does not mean careless.
And this quote right here, it really sums up the whole philosophy. At the end of the day, this isn't just about finding bubbles. It's about asset integrity. It's about making sure a system is leak-free, that it's safe, and that it's ready to do its job. It's about protecting people, the environment, and the business itself.
So if there's one big thing to take away from all this, it's the power of simplicity. In a world full of high-tech sensors and complicated diagnostics, one of the most reliable ways to find a critical flaw in a multi-million-dollar system comes down to a principle we all understand intuitively. And that kind of leaves us with a final thought, doesn't it? We've just seen how a really fundamental principle, escaping gas makes bubbles, is used to solve a high-stakes industrial problem. It's a perfect example of a simple, elegant solution. So it makes you wonder, what other complex problems out there rely on surprisingly simple solutions? Where else is the most brilliant answer, not the most complicated one, but the most fundamentally simple?